So the case of jointly normal random variables makes things simpler and linear. So one of the properties of normal random processes is that when they go through a linear system, they remain jointly normal. And we'll learn about that in next chapter. So conditional densities of normal random variables has this interesting property. So if you consider S and X jointly normal, this is a random variable and this is a random vector. The conditional PDF of S given X, assuming that X is given, becomes the ratio of two exponential function, and the exponents are quadratic. So f of x given s x becomes the ratio of two normal distribution, and this ratio can be simplified and becomes also normal. So the conditional densities, if you have joint normal random variable, becomes also normal, and this means that expected value of s given x is equal to this guy, okay, and is a linear combination of x. Okay, so this is the optimal nonlinear estimator and also is linear estimator. Therefore, this is optimal linear estimator as well. For example, if you have three random variables, and they are jointly normal, then the expected value x2 given x1, you can quickly calculate this one, expected value x3 given x1, and so on, and then you can calculate the covariance of x2 and x3 given x1. You can calculate it using this one. And also you can find the conditional distribution of x2 and x3 given this one using these expressions. So these are the things that you can do exercise. Please spend a little bit of time on this slide because this will help a lot to solve problems.